Welcome to our video lesson on multiplying and dividing monomials. To start, we're going to talk about multiplying monomials. And remember that monomials means a polynomial with one term. So we're looking at multiplying two monomials together, or two polynomials with only one term. To start, like we started all of our different operations with polynomials, we're going to start with algebra tiles. So when you're representing multiplication of monomials with algebra tiles, here are the three steps you follow. First, you represent one factor along one dimension. What that means is along one side, you're going to write one factor. Then you represent the other factor along the other side. So let's start with this side up here. We have three green boxes. Based off of what you know about algebra tiles, what monomial do these three green boxes represent? Well, I know each one represents x, and there are three of them, so that means 3x. Now on the other side, I have two boxes, but they're white. And remember that the white means negative. This means negative 2x. So that means that this question is asking, what's negative 2x times 3x? Well, if you're doing it with algebra tiles, what you do is you fill in the center of the rectangle with the area of each set of factors. So for example, here we have negative x, negative x. I'm going to fill in this part right here with whatever x times negative x would be. Well, x times negative x is negative x squared. So that means I'm going to fill in this section here with one negative x squared box. Then I look down below. Again, I have x times negative x, so I'll have another negative x squared box. Each of these boxes represents negative x squared. Eventually, we fill in all of our sections down below the rectangles with these white boxes. And each white box represents one negative x squared. There are 6 boxes, so that means that negative 2x times 3x is equal to negative 6x squared. Hopefully you're noticing something. Hopefully you're noticing that in order to get negative 6, if we multiply 3 times negative 2, then we'll get negative 6. And if we multiply x by x, we'll get x squared. Maybe there's some sort of hypotheses you can form in your head that might help you think about multiplying monomials. Let's do another example. So here I have 3x times 2y. Now we haven't seen the 2y tiles before. Those are the orange ones along the side here. And they're a slightly different size than our x tiles. So we have one factor represented along the top, which would be our 3x. And we have our 2y represented down the side here. Now to find how much the space would be, we fill it in, we fill in the center. Now we know that across our top we have x tiles, and that along our side we have y tiles. And to find the area of this tile in here, we'd have to do x times y. Now x times y is just xy. So if you have a tile, the gray tile like this inside, it means it's an xy tile. And if we do all our multiplication, we're eventually going to end up with 6xy. So when we're multiplying it down here with our tiles, we have our 6xy. Now we're going to look at how to do it algebraically. If it helps you to have algebra tiles in front of you when doing this, make sure you keep algebra tiles there handy so that you can use them if you'd like to. Let's start with our first one. We have steps over here. These steps probably look familiar to you. These are the same steps from adding polynomials, and you can use the same ones with multiplying. But let's see if we can do it on our own. Instead of writing this as 3x times 2x in parentheses, I'm going to write it out as 3 times x times 2 times x, because that's all that's really being asked in the expression. Then I'm going to rearrange it so that I have my numbers and my variables together. So I'd have 3 times 2 times x times x. Now I'm running out of space, so I'll do it over here. 3 times 2 is 6, and x times x is x squared. So if I wanted to simplify this pair of monomials being multiplied together, I'd multiply the numbers and then multiply our variables. Let's do another example. In this example, I have negative 3x times 5x. Well, I could write that as negative 3 times x times 5 times x. This is an example where it's really important to use the dots instead of the times symbol. Then I could rearrange it, so it'd be negative 3 times 5 times x times x, and that would give me negative 15 times x squared. Now, if you can get rid of some of these steps and do it in your head, that's just fine by me, but I'm writing it out so that everyone can see how it would work. Here I'd have 5 times y times 4 times x. So I do 5 times 4 times y times x. And I know 5 times 4 gives me 20. But can I simplify y times x? No, I can't. So I just have to write it as y x. And if you wanted to write that as x, y, it would be the same thing. I just used y times x because y and x are in that order there. Alrighty, let's do this last one. This last one is more challenging, so let's give it a try. It would be 5 times m cubed, or m to the power 3, times n to the power of 7 times 8 times, times m times n to the power of 4. Now rearrange it so we've got like terms together, or like parts together, I should say. So I'd have 5 times 8 times m to the power of 3, and then my other m, times n to the power of 7 times n to the power of 4. Now let's combine our exponents here using the exponent rules we learned in our last unit. 5 times 8 gives me 40. M to the power of 3 plus the secret 1 that's here is m to the power of 4 times n to the power of 11. Because 7 plus 4 gives me 11, and that would be my answer down there. Ooh, that one was fun. After you do multiplying monomials, we're going to look into Alright, so dividing monomials. To start, dividing monomials is different from multiplying. Remember when we're dividing, we start with how many parts we have. So if I have 5 pieces of chocolate and I want to divide them evenly among 3 people, I'd start with my 5 pieces of chocolate. Well, the same thing is true about dividing monomials. So the first thing we're going to do is represent, in this case it says numerator. So that would be if this was written as a fraction. So let's just write it as a fraction. 8x squared divided by 4x. Oh, that x is very messy. It's kind of like a y. So I'm going to represent the numerator inside the grid. And my numerator is 8x squared. So that means with my tiles, I need 8x squared. So there are my 8x squared. Then it says the denominator represents one dimension of the rectangle. So 4x is one dimension of the rectangle, and that's this side up here. And we can see that 4 x's line up perfectly with my 8x squared. Now the answer, or the quotient, which is the answer to a division problem, is the other side of a rectangle. So if you imagine what tiles could I fit nicely over here to make this fit and to give me the answer of x squared. So hopefully you can see that this one would be 1x, and the one down below would be a second x. So that means that 8x squared divided by 4x is equal to 2x. Hopefully you can see algebraically why that would make sense. 8 divided by 4 would give me 2, and x squared divided by x is x. Let's look at another example with algebra tiles. In this situation, we're using negatives and positives together. So again, we start by representing the numerator inside the grid. And if this was written as a fraction, it'd be negative 4xy on top, divided by 2y on the bottom as the denominator. So negative 4xy. That's what I start represented here. They're white, so that means they're negative. And you'll notice they're not perfect squares like my previous ones were, which means that they're the xy tile. Then the denominator represents one dimension of the rectangle. So my denominator is 2y, which is this side of my rectangle over here where I just put my 2y there. So that means the quotient or the answer will be what I would put along the other side. And what's going to fit along the other side to give me negative 4xy? Well, that would have to be a negative number for sure, so that I can get this negative product. And so it would be negative 2, because we have 2 of them, x. So that means, let me just write this separately, it's really messy. Negative 2x. So that means that negative 4xy divided by 2y gives me negative 2x. And that makes sense because if I have negative 4 divided by 2, that would give me negative 2. And xy divided by y would give me x. Now let's look at how to do it without algebra tiles. If you like algebra tiles, keep them there and use them. There's nothing wrong with that. Now our steps are to rewrite the, oh, these steps are completely wrong, so let's just ignore them. We have 8x squared divided by 4x. We are going to start by dividing our coefficients. So we have 8 divided by 4. Well, 8 divided by 4 will give me 2. Then I have our variables, which would be our x squared divided by x. Now if I wrote this out, it would be x squared divided by x. And I know from our last unit, the rules we did with exponents, when we divide, we subtract. So this is x to the power of 2 minus x to the power of 1. So 2 minus 1 would give me x to the power of 1, which is just x. So that means that 8x squared divided by 4x is 2x. Let's do another one. I have 10xy divided by 5y. Again, let me start with our coefficients. What's 10 divided by 5 will be 2. Then I look at our variables. I have xy divided by y. These y's are going to cancel out, and all I'll be left with is again 2x. Last one down here. Start with my coefficients. What's negative 12 divided by negative 3? That would be 4. And again, I have x, y divided by x. So this time my x's cancel each other out. And all I'm left with is 4y. Hopefully you've got a great start to dividing monomials and multiplying monomials. That's all for this video lesson. As always, if you have any questions, please ask me, and I'll talk to you later.